I have recreated our data table here in a Google spreadsheet. If you don't know how to use Google spreadsheets, that's fine. You should be able to follow along anyway. So here's our days 1 through 6. I couldn't figure out how to do a subscript for H sub I, so it just says hi. So here's our data that we measured how many hours June slept for 6 days. B of I, remember, is our mean equation, the equation for the mean, which is the blue line. And then R of I is our trend line. So R of I is the slope m times I plus the y-intercept, or b. And initially we had used a slope of 0.5 and a y-intercept of 4, which we showed that it did have a smaller total absolute error. So it's better than the mean line, and it's also got a smaller total squared error. So it's better than the mean line for both of the metrics that we're using. Now the question is there a better trend line? What if we used a slope of 0.4 and a y-intercept of 5, for example? Is this better or worse than the other line? So what I've done is I went through and I selected a whole bunch of slopes and y-intercepts, and then I calculated the total absolute error and the total squared error, and then we're going to find the smallest values. So the first one I look at is slope of 0.3 and a y-intercept of 3.5. So this line definitely looks a little bit too low. I then increased the y-intercept by 0.5 up to 5. And then I went over and I increased the slope to 0.4. And then I did the same thing with the y-intercept from 3.5 up to 5. Slope of 0.5, slope of 0.6, all the way up to slope of 0.7. So the highest line we should see is a slope of 0.7 and a y-intercept of 5, which is clearly not the best trend line. Now your first question might be, so how did I go about choosing these values? Going from 0.3 to 0.7, and then for the y-intercept going from 3.5 to 5. Well, I kind of just did it by eye, somewhat arbitrarily. I could definitely have gone in smaller increments. I could have gone from 3.5 to 3.6 to 3.7, but I'm going to say that this is good enough, and that's something that we all have to make a decision about when doing the best fit lines. Is it good enough? Is it granular enough? So let's go ahead and look at our metrics now. The total absolute error. Let's find the smallest value. So we've got an 8.5, 8 is smaller, 7.5 is smaller, 7.2 is smaller. Okay, so 7.2 is the smallest. So the smallest total absolute error was from a line with a slope of 0.6 and a y-intercept of 4.5. And yeah, that looks pretty good. It almost hits 3 of the points. We've got 1 above and 2 below. I believe it. I think this looks like a pretty darn good line. Let's look at our other metric, the total squared error. So 15.6, okay, 14.86, 14.36. Okay, yep, it looks like 14.36 is the smallest total squared error. And that's actually the same slope of 0.6 and a y-intercept of 4, so it's just shifted down a little bit. And yeah, that also looks pretty darn good. So I'm going to switch over to the whiteboard again to explain this a little bit further. Thanks.